So in this video, we're solving the equation 1 over the quantity tangent squared x plus 1 equals 3/4. And on our trig hexagon, tangent squared plus 1 is equal to secant squared. So we're going to start by using that Pythagorean identity to substitute secant squared x for tangent squared x plus 1. Okay, then the reciprocal of secant is cosine on our trig hexagon. So we can rewrite 1 over secant squared x with cosine squared x. Okay, then to undo a square, we square root. Those are inverse operations. And cosine of x then is equal to plus or minus square root of 3 over 2, because the square root of 4 is 2. And that's going to give us an x then that is equal to the arccosine of plus or minus root 3 over 2. So we're looking for the angles on the unit circle that have a cosine, which is the x coordinate, of root 3 over 2 or negative root 3 over 2. And in quadrant 1, this is pi over 2, pi over 3, pi over 4, pi over 6, and 0. And pi over 6 is the angle that has an x coordinate of root 3 over 2. So our principal value, which is our reference angle in quadrant 1, is pi over 6. Cosine is negative in quadrant 2. So if I reflect pi over 6 over the y-axis into quadrant 2, I have 5 pi over 6. Then cosine is also negative in quadrant 3. So if I reflect pi over 6 over the x and y-axis, I end up in quadrant 3 at 7 pi over 6. And then cosine is positive in quadrant 4, so reflecting pi over 6 over the x-axis gets me 11 pi over 6 as my quadrant 4 solution. And we have 4 angles then that we're going to check in the calculator. So we're going to look at the mode, make sure that we're in radian mode, which we are. Then we can store our first angle, pi over 6, as the x. And our original equation is 1 divided by the quantity tangent x squared plus 1. And then we need an equals from the test menu and 3/4. When we press enter, we get a 1, which means pi over 6 checks. Now we're going to check our second solution, 5 pi over 6 from quadrant 2 by storing that as the x. Then we can arrow up, grab that equation, and press enter. We get a 1, so 5 pi over 6 also checks. 7 pi over 6 was our quadrant 3 solution, and that one also checks. Then 11 pi over 6, that's our quadrant 4 solution, and we get back a 1, so it checks.